If you are looking to build, train, evaluate, and test your machine learning models, then Keras is your friend. Keras is an open source API developed by Google for implementing neural networks. Or, in simple words, this is an API in Python which you can use to build your own models. As I said, this API is written in Python and is used to make the implementation of neural networks very easy. It also supports multiple backend neural network computation. It supports TensorFlow, JAX, and Torch. In a recent development, Keras 3 has been announced, which is a total overhaul from the previous version. So Keras 3 completely overhauls the library so that all Keras workflows can be run on JAX, TensorFlow, or PyTorch. This multi-framework support allows seamless switching between backends and custom component development, which significantly broadens machine learning capabilities. In this video, I'm going to give you a demo as how you can build, train, evaluate, and test your own model by using Keras. For this demo, I'll be using Google Colab, but you can try out this on any Linux flavor. This won't really work on Windows, but if you want to use Windows, then you would need the subsystem for shell in the Windows or WSL. So let's get started. So this is my Google Colab, as you can see on my screen, and this is a free version and I'm using CPU. There is also a GPU support, but in this video I'm just going to go with the CPU. The first step we need to do is to make sure that TensorFlow is installed and we have the latest version. So let me quickly put in the TensorFlow command, and I'm using the trusted TensorFlow upgrade with the pip. Let's wait for it to finish. Google Colab comes with TensorFlow installed, but I'm just upgrading it because most of the time it is using the older version, so it's always a good idea to use the latest one. Shouldn't take too long. Let's wait for it to finish. So TensorFlow is done, and if you look at the output, you would notice that it also has installed Keras 2.15, but we want to upgrade it because the new Keras 3 has a lot of capabilities which we will be using in this demo. So I'm just typing pip install Keras upgrade. Let's wait for it to finish. Shouldn't take too long. Okay, that's already done. And you can ignore this warning for now because it is fully compatible with the previous version, which is very nice. Okay, now that's done. Let me quickly import this Keras library. So here what I'm doing is I'm importing these libraries, and I'm also setting the backend to TensorFlow. You can either use JAX or Torch, but I'm going to go with the TensorFlow. Let's quickly print out the version of Keras. So you can see that we are using the latest version of Keras. Okay, now what I'm going to do is first I'm going to download a raw text which will be used as a training set for our model, which we are going to build and train and evaluate with this Keras. And the dataset which I'm going to use is from the IMDb sentiment classification dataset, and it's an unprocessed version. And we'll be using text vectorization layer for word splitting and indexing. And I'm using these example from Keras.io website, and I also will drop the link so that you can also try it out by yourself. Okay, now first let's download the dataset. I'm just curling this dataset from ai.stanford.edu website, and then we are untarring it. Let's wait for it to finish. So this dataset downloads ACL IMDb folder. Let me show you. If you click on this folder icon, this is the ACL IMDb. If you open it, then you will see that it has a train and test subfolder. And then we also have, for example, if you go to the train one, we have this POS folder, and then in the uh, same trend one we have neg folder. So these contain text file, and each of these files represent one review, either positive review or a negative review of the movie. So you can test it out if you want. Okay, now I'll just close it to make some space. Cool. Okay, now what we are going to do is we are going to generate a data set by using keras.utils.data text dataset from directory, and then we will, by using the Keras's own functions, we are going to generate the training, validation and test data sets. Let me paste the code here, which as I mentioned is from their example. So these are the commands which we are going to use. So if you look at it, we are building the training data set here, validation data set, and then test data set, and then we are also printing it out how much data these sets contain. So it is running, it is first doing the train one, then it will generate the validation set and then the test set. Okay, let's wait for it to finish. That's done, and you can see that it has also printed out how many files belong to which data set. Cool. Now you can also review the sets here. Let me print it out. In this code chunk, all I'm doing is I'm just going through the sets and printing out the data set which it has created. That's good. Now in the second step, we need to massage or prepare the data. So as an example, we are going to remove the BR tag from this set. Let me show you the code. So this is what we are removing here. As you can see in this example, this is the tag we are removing. Let's run it. So basically you can remove any unwanted tag or data component which you don't want. Let's wait for it to finish. Takes a bit of a time because it is going through the whole data. That's done, and now in the next step we are going to vectorize the data or convert it into embeddings, which are the numerical representation, and we are simply using this own data set and this vectorized text function that is already done and fairly quick. As you can see, the performance is really good. I know the data set is not that big, but still. Okay, now let's build the model, and let me paste the code and I'll walk you through. So this is how we are building our model with Keras. So all we are doing it, we are using the inputs with the indexes we created above or vectors, and then we are passing these to embeddings, creating a layer on top of it, and then we are using these global max pooling and also add a vanilla hidden layer just to make it more dense, and then we project onto a single unit output layer in this line. Once that's done, we just create our model and then compile the model with binary cross entropy loss and optimizer and accuracy. So let's build it. And if you want to know more about these, this is fairly nicely explained in the documentation. I'll drop the link in video's description too. Cool. Now let's train the model. And in order to train the model, you might be aware of the concept of epochs, that how many passes we need to make to the data set to train the model. In order to save time, I'm just going to go with the one epoch. But normally, in order to get more accuracy and results, I would suggest that you go through at least 3 to 5 epochs. But let's just to save time, let's go with the one epoch. And it will go through these whole 1875 lines in order to train it. And once that's done, we will evaluate the model on the test set. So let's wait for it to finish. Shouldn't take too long because it's a small one. Model is almost built, and as you can see that the ETA is around 40 seconds, and on the right hand side you can see it is also printing out in real time the accuracy and loss. Accuracy and loss are pretty interesting concept. In AI model training, accuracy score is the number of correct predictions obtained, whereas loss is the value indicating the difference from the desired target state. People usually consider and care about accuracy metric a lot, but they tend to ignore the loss. But I believe that loss is also something equally important and taken care of. Anyway, the more epochs you will have, the more your accuracy and loss will be, I would say, representative. But don't overdo it. 3 to 5, depending on the data set, is enough. As you can see, I have just done the one epoch, but for this data set, I think 3 epochs should be fine. There is no hard set rule. Unfortunately, you have to just do it through trial and error. Anyway, so this is almost done. Let's wait for it to come back. Once it is there, I am going to do the evaluation on this data set for this new model. Let's wait for it to finish the fitting. Okay, so the model training is done. Now let's do the evaluation on the test data set. And the command is simple, model.evaluate, and you can see that it is now testing here. And then it is also telling you the accuracy and loss. Let's wait for it to finish. Shouldn't take too long. It is fairly quick because our data set is small and the test data set is simply 782, which is almost done, I would say. So model evaluation is done, and as you can see, the accuracy is pretty good. I would say it is 7, close to 8, and closer to 1 is better, and lower the loss, the better. Even with one epoch, I would say these are quite good numbers. Anyway, now another thing which you can do, you can build a new model out of these weights which we have just trained. So all we are doing it, we are just using those as input, turning them in indexes, outputting it, and then we are creating our new end-to-end model, and then we are testing it out with these simple commands. So if I run it, it is going to do the same thing after building the model on the same data set, as you can see, which we did previously. And it will finish and it will print out our accuracy and losses. Let's wait for it to finish. And as you can see, that's done. Still our loss is higher and our accuracy is lower because it's one epoch, but which is not good at all. So we need to train this model more. But this is just an example. You can do multiple iteration and then you can train it more to get this better. But of course we can't overdo it, otherwise the model will overfit, which means that model might just memorize the whole data set. Anyway, that's another topic for another discussion. But we are focusing on Keras here. So you can see Keras is really cool, easy to use, written in Python. You can do a lot of things on it. You can build, train and evaluate and test model very easily. So that's it, guys. I hope that you learned something and enjoyed it. If you have any questions or thoughts, please share them in the comment and I'll be happy to answer. And if you like the content, please consider subscribing to the channel and give the thumbs up. Thank you very much.